Hey folks, Segasonicfan here. Today I'm going to show you quickly how to fix your Stanton mixer power supplies. Whoo boy, was I sweating when this broke. This sucker is really rare and really hard to come by. And what do you know, 16.8 volts AC at 1 amp? Good luck finding that. Even worse, it's not actually 16.8 volts. It's 42-ish, or I'm sorry, 32-ish, because it's there's actually two 16-volt outputs that are complementary, so it can make more voltages. It's a really screwy, funky, weird kind of power supply that you'd have to hack with two separate 16-volt AC power supplies with a common ground. It's really no fun. And when that broke, I was just really sad when it broke today because I love my Stanton mixer. And before I knock over my tripod here, I'll show you what I have and what I'm talking about. This is the Stanton SA-5. It's all kind of dusty and hard to see. Let's see if I can get some better light on here. Anyway, this mixer is my favorite mixer in the world ever. I mean, I'm sure they make other mixers that are probably even better. But I really love this mixer because of the Penny and Giles knobs and the really easy low, mid, and high EQ. Just really easy on my hands to adjust, and it sounds great. It's got a bunch of features, of course. It's got a mic input, Q leveling. It's got a whole bunch of stuff. It's a cool mixer, and it's not cheap. I mean, they're a couple $100, but the power supply, if you can find it, is going to be more than half the cost of the whole mixer. So why is that? Why does it need such a specialized power deal? Well, because it's loaded with friggin' preamps. And for audio stuff, people don't like to use switching power supplies very often. And also, when you're doing this much with preamps, it makes more sense to have multiple voltages. Most preamps are going to be dual voltage, and then if you have different kinds of preamps wanting different kinds of dual voltages, you already have 4 different voltages right there. All you need is 2 preamps with different voltages. So yeah, that's why they did it, I'm quite sure. And if you look at this this power supply board, you might think, well, it's not that beefy. Actually, these wires go to some TO220 package voltage regulators, likely 15 volt. I think they're 7/815s, really common linear voltage regulator. What's really cool here is they actually wired them in and put them on the case instead of having them here. Either they did that or I did that. I think they did that. Though I guess it's possible. Nah, it looks pretty clean and the wiring matches really well. So I think it's something that they chose to do so that the voltage regulators weren't stuck in here without a heatsink, which is cool, especially because you have this big ass resistor that's going to be producing a fair amount of heat, which, by the way, should not be so close to these capacitors. I did replace one of these capacitors, or maybe all of them at some point. I've had this thing for over 10 years now. Maybe 9 years. I don't know. I've had it for a really long time. And I use it constantly. I really like it. And you can see here what really tipped me off to why I needed to fix this power supply is the bridge rectifier stage. Bridge rectifier, just 4 diodes. But you'll see here there's 8 diodes. Which means we have 2 bridge rectifiers, which means we have 2 likely AC inputs. The other tip-off, of course, is you have a 3-pin plug, both to this board and to the outside. I was kind of hoping one of those would just be like an earth ground or something, but no, it's dual voltages. So there's actually 2 16-volt AC power supplies. It's actually around 18.3, something like that, without a load. AC voltages change when you apply a load. And there's no capacitor inside the power supply itself, so it relies on these capacitors in here. You'll notice there's really no fuse anywhere. Not a fan of that. You should always have fuses. And so that had me quite worried. And you'll notice it also relies on this very large toggle switch, which is toggling all these different contacts at once. Yes, it works still, which is nice, but something this mechanically oriented is prone to failure. And the better way to do that is using a MOSFET switching circuit. But, they're saving costs. This thing's already expensive and really nice for what you get. What else can I say about this? The phono stage is decent. It's not going to blow you away, but it's quite decent. But everything about this is prosumer, I guess you could say. It's just, but what you're really paying for, what you're really getting with this thing is the nice fader knobs. And I don't know. I'm just nostalgic for it. Maybe I could buy a better one for a couple $100, but I like it. So your power supply blew up. You're sad like me. This totally ruined my day and possibly my week because I use this thing so much. And I was ready to give up. I ended up ordering a power supply off eBay that was 16 volts AC, and then sort of scratched my head and thought, you know what, I should see if I can fix this. And when I was doing that, well, you know what, this is actually two 16 volt AC power supplies. So, lucky for me, I was watching some videos on YouTube for how to repair transformers because I realized this thing is so specialized, I need to just try to repair it. There's a really cool video that I'll try to link called Making Stuff with David or something like that, where this guy actually removes all of the plates here and uncoils the wire to find a thermal fuse inside the transformer between the primary and secondary stage. Primary stage, by the way, is the AC voltage. The secondary, so they're both AC, but the primary is the line voltage and the AC is after it's converted. So you can, transformer is just a bunch of coiled wire with magnets. That's pretty much all it's doing. But of course, it's done with a certain amount of turns and a certain amount of electrical current running through a magnetic field to create the output voltage that you want. It's really the most basic thing of like all electricity. One of the most basic things, electromagnetic transformer, and it's pretty cool. So that said, how can these break? Well, sometimes the wire will actually melt inside the transformer, and that's really bad. If you're lucky, sometimes there'll be like a break or a melting point from just the input where the fault happened. And then this was covered in all this red tape stuff. So I was like, well, with my luck, it's probably melted inside. Lucky for me, and holy shit, lucky for you too if you're watching this video, there is actually a thermal fuse that looks like so, which is on the primary side near the line level input. See if my camera will focus. Come on, camera, focus. Try to move it closer. Maybe block the lens. Sometimes it helps it focus. Come on. There it goes. M2005C. So these are very, very cheap. They're about 5 or 10 cents each. You can get them on all sorts of sites. And it's just a thermal fuse that's set to blow at a particular temperature, in this case 115 degrees Celsius. And of course it'll be rated at 120 or 130 volts or something like that. So yeah, very excited to find that. Very, very excited. Of course it was blown. How did this thing break, by the way? How was it blown? Well, I just had it under a bunch of stuff, and I think it just got too hot over time and just blew that fuse. I don't think there was actually a fault anywhere. But lo and behold, I just went in here and soldered a fuse holder like so. Found a really low current fuse just to give it a test run with no load applied. It shouldn't blow even a really low current fuse unless there's a fault. And I also measured the primary side. Now, watching a video on YouTube, I saw that sort of a standard rating would be around 15 ohms. Something like that. This actually gets 14 ohms, something like that. Anything probably between 10 and 20 ohms is probably pretty standard. Really depends on, how much coil is wrapped around, which ultimately is, the resistance of the wire when it gets back to the AC line. Anyway, that's all, math and stuff. Physics of electromagnetic induction and all that good stuff. But so this was around 14 ohms, which was really, really promising. And I put in this fuse and I powered it up with gloves. Be safe. Make sure you isolate everything else from your AC wall outlet when you do this, because if something goes wrong, it could potentially blow up everything on that AC outlet line. Have your fire extinguisher close at hand. Gloves, proper precaution, electrically insulated gloves. And Anyway, I took the proper safety precautions, plugged everything in, and I got 18 point something volts on across each of these outputs. There's three. You'll see there's 3 pins there. 1, 2, 3. This is the center, and then this is a 16 volt AC, and this is a 16 volt AC, or 16.8. Like I said, without a load, it's like 18 point something. So once you apply a load, it falls back down a bit. And what was I talking about? You can't put capacitors on here. These are AC. So yeah, the capacitors are on the DC side, not the AC side. Duh. But yeah, now it should be all good once I put it all back together. It's a bit of a clustery mess right now. But also the AC line was mounted on this. The tape went around here. And of course, this is an insulator and divider to make sure that you don't touch the primary voltages. Got to be very careful of that. And if you're going to be doing this and putting everything back together, I highly recommend using Kapton tape to kind of rebuild everything. This is a thermal insulating tape, which is great stuff. Polyamide is also what it's called. I think Kapton might be a brand name. Polyamide is what it's manufacturers call it. So yeah, I'll have to find one of these actual fuses, but for now I might be able to rig something up temporarily so I can play music tonight. Yes, life is good again. And moral of the story here, don't buy mixers with crazy wonky power supplies. In fact, my newest mixer is actually a Yamaha, and I bought it specifically because it uses a 12 volt DC power supply, and it's like small with a couple of features. It's called the MG06X. That's my current mixer. It doesn't have those nice fader knobs. It's much cheaper, but holy shit, it runs off 12 volts DC, which means I will never have these kind of problems with it. Avoid things that have specialized AC brick power supplies. It's really annoying to have to try to source super rare, weird, custom power supplies like this. Fortunately, I repaired this one. I am repairing it. Will be repaired soon. So again, this is the power supply. This is used in like 5 different or 6 different Stanton mixers. It's very hard to come by. I could find 0 copies for sale. And to open this, I don't know if anyone has tricks out there to open these. I ended up taking a rotary tool, and my go-to is the Dremel rotary tool. It's pretty damn popular. And I used a thin cut blade, and this is the quick release thing they have, which is pretty sweet. Anyway, you put this on there, get some proper ventilation going, and just go very slow. Try not to push it in too far, of course. You don't want to hit the core there or whatever else is on the inside. And that's my way of opening these crazy glue molded power supplies. I actually put this in the freezer for a while to see if that would loosen up the glue. And even after cutting sort of an opening and using, because sometimes you can do a trick where you cut a little bit of an opening and then you put in a flathead and try to pry it, and that did nothing, folks. This thing is really glued together. So yeah, the drill technique works. They do that, by the way, of course, for safety. They don't want you going inside these things and electrocuting yourself or burning your house down. Fortunately, I'm here to encourage that. Just kidding! No, all the precautions apply. If you kill yourself, don't blame me. But put your records in your will for me because I want them. JK. Yeah, please be safe, folks. Gloves, fire extinguisher at hand, electrical insulating gloves, rubber gloves. Have somebody, in the house near you, or, close by at hand in case something goes wrong, kind of spot you. Be very careful working with AC voltages, primary voltages of any kind. So, yeah, that's it for this video. Have fun repairing your turntables, your mixers, all that good audio stuff. No reason to give up on a transformer. This one will be saved. Yay! This is Segasonicfan, signing out. All right, back here for a part 2 of the Stanton. Very rare, very important power supply. The AC to AC adapter, which cannot be replaced because I couldn't find a single one for sale. These are 16.8 volt, sorry. How specific is that? AC and AC again. There's 2 AC outputs, actually. These 2 and these 2. So this is ground, which is the common, and then it's a split power supply. Very hard thing to come by. I'm so lucky I was able to repair this. Holy crap, that is very unusual to be able to repair a brick power supply like this. But there was a thermal fuse which I replaced in here. This is the one that it normally comes with it. It's a 115 degree M20 fuse. These are really cheap, fortunately. You can get like 10 of them for $1, but you have to wait months, and I didn't want to wait months. So, or even, you know, a week or whatever. I really want this thing working now because I love this turntable and I really want to listen to music. I always listen to music. So how did I find a thermal fuse? Can anyone guess where these are from? I'll give it a second for the regular viewers. These are from the backlight to a Sega Game Gear. Same deal, high voltage, AC, and so they need a thermal fuse. Pretty cool, huh? So I have a bunch of those in my parts bin, because I'm always working on Game Gears. And the trick to these, though, is that the thing you have to really know is these break so easily. When you solder them, they will blow up. They're really sensitive to temperature. That's kind of their purpose. So the trick that I found is to use a pair of tweezers like so, or pliers. These are more like pliers than tweezers, really. So you hold them like this when you're soldering to it. You can also put it in a clamp and do other things like that. But this worked really, really well to heat sink it. The other important thing is you don't want to clip the leads shorter. So you have to get a lot of heat shrink tubing and or polyamide tape to cover it up pretty well because you can't shorten it or it will break it if you're soldering, you know, even half this length of a lead. So that was the trick to know. And then for the other two on the secondary side, I just used Pico fuses, since those are a little bit more resistant to temperature and more likely to blow if there's an electrical fault that's, you know, doesn't have to be super, super sensitive. So yeah, I'm going to put this back in the case. I've wrapped it around with a few rounds of polyamide tape, and it's layered as well in sections. So you want to do a layer before the fuse, a layer after the fuse, and then a layer all around. Polyamide tape is heat resistant, and it's great for this kind of an application. And I already tested it on my table. Everything works like a charm. Just a quick note on the plug adapter. I totally hate this plug. Oh my gosh. But it's what there is. It's a 3-pin connector, of course, for the dual voltages. And it's very, very easy to break it because it's just not made very well. There's a screw under the securing nut here. So you have to undo that screw, and then of course the two screws here that have the clamp for the cable. I found that the cable was too thin for the clamp. Maybe there's a piece missing of rubber or something from years ago. I just wrapped some Gorilla Tape around to give a nice adhesive onto the cable, but then also kind of widen it so the clamp works a little better. That should be pretty good. And but if you have to work on this, you have to take out those 3 screws, and then you have to really tug on this guy. Hold the metal and then tug on the black plastic plug, because there's actually kind of a little bit of a grip plastic that kind of clicks into the slot here. So anyway, it's not fun to work on. It's kind of a pain. There's a little plastic insulator ring, but it's not great. So I put some polyamide tape in there as well. Back in the day, I used to just hot glue these. And that can work a little bit, but if you have to work on it again, it's kind of a pain. If you do have to get hot glue out of a cavity like this, the way to do it is using isopropyl alcohol, by the way, and a little bit of heat. So yeah, I'm going to put this back in the case. I'm going to hot glue the case. Now, some people do super glue or whatever. I'm just going to hot glue it because you never know if those fuses will blow again. And I'll be ready to go with a working original power supply, now all fused and protected. And I'm going to take some pictures and also a couple measurements from the Stanton itself, because if anything happens, you never know, I might need to rebuild a power supply of my own. So I want to get those DC voltages while I can. One thing that's worth noting is that the Stanton supply, the power board in the Stanton mixer that this is for, really wasn't designed well for these kind of failures. This 3-pin plug right here, this JST, it's probably a JST plug. See those three connectors, the 3 pins on that connector? Super wide traces, folks. You see those super wide traces going straight down to the switch? So bad, because that means if there is a fault, it's not going to burn off the trace. And of course, ideally, there should be a fuse. Given that this is only outputting an amp total, there's no reason for those super wide traces. I mean, there's a negligible power loss in a thinner copper trace. But Yeah, I would have really opted for 2 fuses in there, especially given what this thing costs. To not have fuses is kind of silly, very silly. So yeah, not a lot of things I can fault with the design, but that's definitely one of them. So yeah, folks, when you're doing your power supply design, please include fuses, and don't make really wide traces if you don't. And yeah, serviceable parts is always nice, and holy crap, sometimes you can actually save a transformer brick power supply. Go figure. Also, don't buy things that are AC output. If you have to get a mixer, get like the Yamaha MG06 that I got, which uses 12 volts DC. Avoid as much as you can any of these AC coupled output or AC output power supplies, because they are just going to drive you crazy if they ever have a problem. That's it for this video. Segasonic Fan, signing out.